All right, so this lesson is about division of polynomials and the remainder theorem. If you have a textbook at home, this information is not out of an Algebra 2 textbook, so you're not going to be able to find it in your Algebra 2 textbook. The big thing that we're working on here is that when one polynomial is being divided by another, the answer or the result can be written either as a rational expression or as a quotient polynomial, meaning an answer polynomial, with a remainder polynomial. And that's what we're going to head towards. So our goal here is to cover some polynomial long division and to look at the remainder theorem. Our job is to find the quotient and the remainder when one polynomial is divided by another polynomial of lesser degree. So we can do x squared divided by x, but we cannot take x to the fourth and divide it by x to the fifth. What we're dividing by has to have a lesser degree than what we're dividing into. In order to do this long division, what I'd like to start with is just a reminder of some of the long division of integers that you covered in elementary school. So for integers, there's two ways of looking at division. Consider dividing 47 by 16. Okay? A rational number, rational means we're talking about a fraction, a rational number division. So the quotient, or the answer, is 47 over 16, or if we put it in the calculator, we would get 2.9375. And that's a single rational number. But if we're talking about real life scenarios, a lot of times what we want to see is a whole number or an integer and which part is left over or which part is a remainder. So when we do, and we're looking for integer division, two numbers for its description, but has an advantage that no new numbers, we're not bringing in any rational numbers, we're not bringing in anything weird to it, we're just dealing with integers. So let's remember how to do our long division from elementary school. The thing we're dividing by goes out in front, and the thing we're dividing into goes underneath the bar. Okay? What I need to do is I need to focus on this number that's out in front, the thing I'm dividing by, and I'm going to check each number as I go. 16 to 16 divide into 4. We'll know 4 is way too small for that. So I'm going to have to go to the next digit. To 16 divide into 47. Well, I'm sure it does. I just am not totally positive how many times. So I can come over to the side and I can do a little bit of work to figure this out. I can do 16 plus 16 and see if it goes 2 times. So that would get me an answer of 32. So it would definitely go 2 times because 32 is less than 47. But let's see if it can actually go an additional, a third time. So what if I take that 32 and I add a third 16? What will I get? Well, I get 48. And that's too much. I can't go that high. Once I reach to a number that's higher than what I'm dividing into, I know I've got everything I can do. So what I'm looking at is that there are 2 16s that can actually go into 47, 2 whole 16s. Okay, and once I put this number up here, then what I do is I actually multiply these two together. So I do 2 times 16, which we already found out was 32. And I have to subtract that 32 from the 47 that's there. When I do that subtraction, I get 15. Now, I know I'm finished when I have no more digits left here underneath the bar that I haven't addressed, and the number here is smaller than what I'm dividing by. And both of those cases are here, so I know I'm finished. So in elementary school, you learn to write this answer as 2 with a remainder of 15. But we're more mature and smarter than that now. So the way we're actually going to write this answer is 2 and, we're going to use a plus sign for that and, what's left over is 15 that I haven't divided in by 16 yet. So this is the way we're going to write our answer. Most people would see this as a mixed number, which it is. And when we write mixed numbers, we usually don't have to write that plus sign. So we would write it as 2 and 15 sixteenths. But in order to lead us to the polynomial division we're going to do a little later, we're going to go ahead and put that plus sign in there for now, because that's going to help us out. So we're going to try 2 more real quick, and then we'll go to a word problem and make sure we've got long division under control before we start applying it to polynomials. So let's go ahead and do a very simple one. Let's look at 19 divided by 5. Again, what's on the bottom? The denominator goes out in front, and the numerator is what goes underneath the bar. So again, I take my 5 and I look. Does 5 go into 1? No, it doesn't. So then I have to look at the next, the 2-digit number. So does 5 go into 19? Well, sure. So if again I come over here and I look and I do 2 5s together, that gets me 10. Great. I know I can do 2 of them because 10 is less than 19. Let's see if I can do a third. So 10 and a third 5 gives me 15. Oh, well, that's good. I know I can do 3 because 15 is less than 19. Let's see if I can do a fourth. So 15 plus 5 more would be 20. And we can't do that because 20 is larger than the 19. So we know that 5 goes into 19 3 whole times. And now we're going to try and figure out what's left over. So if I do that multiplication, I do 3 times 5, which gets me 15. And I'm going to be subtracting that number. So that gets me 4 left over. And again, remember the qualifications that make you tell it's done. I have no more digits to approach here in underneath the bar. I'm done with them. And this number that I'm left with is smaller than what I'm dividing by. And that's the case here. So I know my answer is, and I'm going to write this the way we want to do it for polynomials, 3 plus what's left over what I'm dividing by. So that should be what we get. And you and I know from earlier on that this should be 3 4/5. That's what's left. Okay, when we do that division. All right, let's try one more of these before the word problem. Something a little bit more difficult. Let's look at 349 divided by 2. Okay, so again, just like we saw before, the 2 comes out in front and the 349 goes under the bar. Now I wanted to show you this one because it doesn't automatically just go into the whole thing. Remember I said we need to check each digit. So does 2 go into 3? And it does. 2 goes into 3 one time. Okay, so I put that 1 above the 3. Now I do my multiplication and I get 2. And notice I put it just below the 3. Okay, we'll do something with that 4 and that 9 in a few seconds. So then I do my subtraction and I get a 1. Okay, and I know I did it as best I could because this 1 is smaller than the 2. But in the last problem, when we got to this point, we said, okay, I'm done. But remember, there was 2 qualities it had to meet. This number, this 1 had to be less than the 2. And I also had to have done something with every digit underneath of the bar. I haven't done that yet. So what I have to do is I have to take this 4 and bring it down. And instead of being 1, it now turns into 14. Okay, so now can 2 divide into 14? In fact, it can. It goes in there 7 times. And when I do that multiplication of 7 times 2, I get 14, which leaves me 0. Now this number 0 is less than 2, so that's good. But I haven't touched the 9 yet. So now I have to bring the 9 down and say, okay, does 2 go into 9? Well, it does 4 times. When I do that multiplication, I get 8. And when I do my subtraction, I get 1. So now this number, the 1, is less than the 2, and I have done everything I can underneath of the bar. So I know I'm finished. So my answer becomes 174, and what's left over is the 1, and what I'm dividing by is the 2. So that's my result there. Okay? So now let's check out a word problem. So we have a farmer who harvests apples from his field. He's putting 50 apples into each bushel basket. He intends to sell each bushel basket to the wholesaler, and he promised his daughter that she could have any leftover apples to take to school. The harvest netted 3,087 apples. What is the maximum number of bushels that can be offered to the wholesaler, and what number of apples does the farmer's daughter get? Well, the number of bushels is going to be the whole number that we get. And the number of apples that the daughter gets is going to be our remainder. Okay, so we're going to take 3,087 and we're going to divide it by 50. Now, one of the things that I want you to notice that I'll reference in the next couple videos when we do the polynomials is you see this placeholder here of 0. Okay, so when we look at polynomials, we're going to have to make sure we have every place accounted for, or every degree of x accounted for, and if it's not there, we're going to put a 0 in. So we have a placeholder. All right, so my 50 goes on the outside, and my 3087 goes on the inside. So does 50 go into 3? No. Keep going. Does 50 go into 30? No. Keep going. Does 50 go into 308? Yes, as a matter of fact, it does, and it goes 6 times. So I'm going to go ahead and do that multiplication, and that multiplication gets me 300. Okay, I do my subtraction. Be very careful about how you line things up so you know what you're getting. When I do my subtraction, I get an 8. So my 8 is smaller than 50, so I know the 6 was right. But I haven't used the 7 yet, so let's go ahead and bring that 7 down. So does 50 go into 87? And it does. It goes in 1 time. 1 times 50 would be 50. And when I do the subtraction, I get 37, which is smaller than 50, and I've used every number here. So that means 61 bushels go to the wholesaler, and 37 apples to the daughter, because that's what was left over. If I write this in terms of the way we've been writing it and the way we're going to do polynomial answers, it would be 61 plus 37 fiftieths. That's how we would have written that answer.